Let's continue our lesson with limit of function, and what we are going to look at is limit involving infinity. Limit involving infinity. So limit involving infinity of a function can be written as a limit of a function f of s. Let's say s approaches infinity. Okay, so this is an infinity sign. All right. So this is how a limit of an infinity can be written. That's how a limit of an infinity can be written. Okay. And approaching infinity means that it is approaching what? The limit, the x here is approaching a very large number. All right, a very large number. That means the x is approaching an infinity. That means a very large number. Okay, so let's take note of this. Number one, if I have a limit of a function, let's say 1 over x to the exponent of n, and then x is approaching, let's say, an infinity, then this particular function here will also be approaching 0, provided that the n is what? Is positive. The n is positive. For example, if I have something like this, if I have, let's say, the limit of a function s approaches infinity, and then this will be 1 over an infinity. Okay, so the x is a very large value. Okay, exponent of n. Okay, so what is happening where the n is positive? So the n can be 1, 2, 3, or 4. So what is happening is that what we are saying here is that assuming that we have n as a very large number, and it is a denominator 1 over that very large number, and then we have an exponent of positive. Okay, it can be 1, 2, 3, 4, whatever it is. What it means is that because the value here, okay, is an infinity, that means a very large number, then the number, okay, will be approaching towards, will be approaching, or the function here will be approaching 0, and it is the same as 1 over infinity, which is equal to 0, positive, so equal to 0. All right, okay. Or we can even give an example like this. Let's say limit of, as s approaches infinity, maybe 1 over let's say 3 exponent x. 3 exponent x. Okay, so what happened is that if the x is also the value of the infinity here, okay, the x is also approaching infinity, and then the infinity here is also an exponent. Okay, so then what is going to happen is that the value of the function will also be approaching 0. Let's say I have 1 over 3 to an exponent of 100 billion. Okay, very large number. Then it means that this particular function is definitely getting to 0. It will be approaching what? It will be approaching 0. So what we have, anytime that the denominator is very large, okay, anytime the denominator is very large, it's approaching infinity, then it means that the value will be getting close to what? Will be getting close to 0. So we say that it's equal to what? It's equal to 0. All right. So that is what we have to take note of. Number 2, let's also take note of this. So the limit of x approaches infinity, let's say s exponent n, where n is positive, does not exist. So we say that we have a limit of a function s exponent n, okay, where the s approaches infinity, and then the n here, the exponent here, so the exponent here is positive, then it means that the limit of the function may not exist, because we are going to have a very large number, and then we cannot know the large number, so the limit will not exist, because here it will be an infinity, okay, approaching infinity, so it's definitely going to be a very large number which we may not know. So the limit may not actually exist. All right, may not actually exist. Okay. We also have something like this, okay, and then let's say 3. Also, let's see if we also have the limit of a rational function where s also approaches infinity. Let's take it for instance like the limit of as s approaches infinity. This is my function f of x divided by, let's say, g of x. Okay, so if you have a rational function, okay, then what it means is that with a rational function, to want to find the limit of an infinity, then you have to divide the limit by the highest power of the x. So let me give an example. If I have the limit of this particular function, let's take it, I have a function like this. The limit of the function 3 squared plus 1 all over s squared as s approaches what? Infinity. Okay, if I want to find the limit of this one, we are saying that with a rational function like it, divide through by what? The highest power of what? The highest power of the x. What is the highest power of x? S exponent 2. Okay, so we are going to have the limit as s approaches infinity. So the highest power of s is s squared. So we have 3s squared over s squared. Okay. Then plus 1 over s squared all divided by s squared also over s squared. So when you divide the rational function by the highest power of x, then it means that you'll be able to come or get your limit. Okay, so let's see. We will have the limit as s approaches infinity. So this will cancel this, then here will give me 3 plus, look at here, if the x is approaching infinity, okay, then what it means that the denominator value here is going to be what? Is going to be a very large value. And if the denominator is a large value, then what happened to the entire expression or the entire function here? It here will be 0, so plus 0. Because as the denominator is becoming a very large value, the expression will be approaching what? Will be approaching 0, so it will be 0. And then over s squared, s squared will give me 1. So that will be 3 plus 0 will be 3 divided by 1. And then my answer, 3 over 1 will give me what? Will give me 3. So the limit of the expression or the function 3s squared plus 1 over s squared is equal to, as s approaches infinity, is equal to 3. Okay, let's consider the questions. So we have to evaluate a, the limit of the function 3s cubed minus 8s plus 5 all over s cubed minus 1 as s approaches infinity or s tends to infinity. Okay. Okay, so this is how we are going to do it. So we will take the highest power of x. What is the highest power of x? S cubed. So we write the limit of the function. So we have what? 3s cubed over s cubed minus 8x squared, 8s over s cubed plus 5 over s cubed all divided by s cubed over s cubed minus 1 over s cubed. Okay, so we have the limit as x approaches infinity. So s cubed can go into s cubed. Alright, then what are we going to have here? 3 minus x over s cubed will give us 8 over s squared, all right, plus 5 over s cubed, all divided by, this will go here, 1 minus 1 over s cubed. Okay, so this is what we are going to have. This will be 3 minus, as s approaches infinity, the s is a denominator. So because it will be a very large value, it will make this particular expression 8 over this to be 0. And then s is a denominator, the infinity is a denominator, so that will also be 0. 1 minus, the infinity is a denominator, okay, and that will be a very large value approaching 0. Alright, so we will get 3 divided by 1, and our answer will be 3. So the answer is 3, alright, as s approaches infinity. Okay, so the B, I have the limit as s approaches infinity So what is the highest power of s here? It is x. So we are going to divide through by what? By x. Okay, so we are going to have, now let me continue down here. We are going to have the limit as s approaches infinity to be 5x over x, 1 over x, all divided by x on x, and then minus 3 also on x. Okay, so x approaches infinity, x will cancel x. Okay, so I'm going to have 5 plus 1 over x, and then x will cancel x, 1 minus 3 over x. Then what is going to happen? We'll have 5 plus infinity as a denominator, so 0, 1 minus infinity as a denominator, so 0. We have 5 over 1, and then that will give me 1. So my limit will give me 5, okay, as x approaches infinity. As s approaches infinity. Let's solve the last one. It said the C, the limit as x approaches infinity, we have what? 5s squared minus 2x, all divided by 3s squared plus 4. Okay, so we divide through by the highest power of x, which is what? S squared. Alright, so we are going to have the limit as s approaches infinity, 5s squared divided by s squared minus 2x divided by s squared, all divided by 3s squared divided by s squared, and then plus 4 over s squared. So we divide through by the highest power of x. So x approaches infinity. We have 5. 2 over x squared will give us 2 over x. Okay. All divided by s squared cancels. So I have 3 plus 4 over s squared. Then as s approaches infinity, we have 5 minus 2 over x. So the infinity will be a denominator, so that will give me 0 over 3 plus 4 over s squared. That will also be 0. So I'm going to have 5 over 3. So my answer is going to be 5 over 3. Okay, as s approaches what? As s approaches infinity. Okay, so this is about the limit. Okay, this is about the limit. Make sure that you like our page, you share, and then you subscribe. Let somebody know about this page. Okay, it's going to help somebody. to pass his or her exams. I will see you once again. Bye bye.